Hi guys, today we're going to learn about increasing and decreasing functions and the first derivative test. Let's start with the first definition. We have that a function is increasing on an interval if for any two numbers, let's call it x1 and x2 in the interval, x1 is less than x2 implies that f of x1 is less than f of x2. We say that a function f is decreasing on an interval if for any two numbers x1 and x2 in the interval x1 is less than x2 implies that f of x1 is greater than f of x2. Okay, so this is the informal definition that you have back in Algebra 2 and Pre-Calculus. Now we are in Calculus, so we're going to use derivatives to conclude about increasing and decreasing. Now that you know how to take derivatives, what we're going to do here, the test for increasing and decreasing functions, is if we have that f prime of x is greater than 0 for all the x's inside the interval AB, then we say that f is increasing, okay, on your interval AB, okay. Similarly, we have that f prime of x is less than 0 for all the x's in the interval. Then what we can conclude is that f is going to be decreasing on that interval that it's a comma b. Okay. The last detail that we have here is some students usually ask me, what happens if f prime of x is equal to 0 for all the x's in the interval? Then what you can conclude is that f is constant, okay, on the interval a comma b. Okay, that's what you can conclude. Now let's move on to one of the most important things of today's lesson, which is the first derivative test. The first derivative test, what it tells you is that if you have c, that it's a critical number of a function f, that it's continuous on the open interval I containing c. If this function f is differentiable over the interval, except maybe at c, then you know that the point c comma f of c can be classified as follows. If f prime of x changes from negative to positive at x equals c, then the point c comma f of c is going to be a relative minimum of the function f. If f prime changes from positive to negative at x equals c, then the point c comma f of c is going to be a relative maximum of the function f. Now let's say that f prime is the same sign, okay, the same, okay, sign, okay, on both sides of x equals c, then what you have is that the point c comma f of c is neither a relative maximum nor a relative minimum, okay. So that's what you have. This is the first derivative test. I hope that you like it. Okay, now let's use it. Okay, so for this example that we have over here, you need to find the intervals where f is increasing, decreasing, identify all the points that are relative max or mins, and justify your answers. The most important part that we have is justify our answers, okay? So what you're going to do here, since we are talking about increasing, decreasing, you need to take the derivative of your function f. So let's do it. You have that the derivative of this beautiful function f is going to be equal to x squared minus 2x minus 3. Once you have the derivative here, what you are going to ask yourself is that derivative undefined at any points? And the answer is no, because this is a quadratic equation, so you know that it's defined everywhere. Now let's go ahead and equalize this to 0 to find your critical numbers. So you factor out this x minus 3, x plus 1, right, equals 0. Okay, so what do you have here? I have that x equals negative 1 and 3 are going to be pretty much what gives you the 0 here. Therefore, these are critical numbers, both of them. So what I recommend you to do here, what I can recommend you to do here is do a table. Okay, so this is not required. You can do it in different styles, but I do like the tables. Okay, so you have from negative infinity to negative 1, negative 1 to 3. 3 to infinity. Please note that here I'm using the entire domain of your function and then the critical numbers, okay? So put them in order so everything is tidy, organized, and nice, okay? So what are you going to evaluate here? You're going to evaluate the first derivative. Why? The test for increasing, decreasing, that is the first thing that we're testing here, tells you that if the derivative is positive, you have that it's increasing. If the derivative is negative, you know that it's decreasing. Therefore, I'm going to select a number in between negative infinity and negative 1. In this case, I would select, let's say, negative 2. Okay, negative 2, plug it into the derivative because that's the one that we're testing. I would plug it in the factor out so it's easier for you. If I plug negative 2, this factor is going to be negative. This one is going to be negative, so this is positive. Similarly, I would plug a number between negative 1 and 3. In this situation, I would do the 0. If you plug 0, this is negative and this is positive, having that interval negative there. Okay? If you plug any number in between 3 and infinity, I would plug 4. If you plug 4 here, that's positive. This is positive. Positive times positive, positive. So you have that the derivative in this interval is positive, in this one negative, and in this one positive. Meaning, what can you conclude for f? F is going to be increasing there, decreasing over here, and increasing here. Okay? Moreover, look at the first derivative test. The first derivative test tells you that if f prime changes from what? Positive to negative, you have a relative max. Negative to positive, you have a relative min. Okay? So now, please note that the table will not give you any points for my test or the AP test. So actually, you do need to conclude. Are we okay with that? So what can we conclude? We have that f is, let's start with increasing. Okay? On the interval, what? Negative infinity to negative 1, and the interval 3 to infinity. Why? Because what's going on there? Okay, f prime is what? Greater than 0 there. Okay. Similarly, what we have is that f is going to be decreasing on the interval negative 1, 3, because f prime is less than 0 there. Okay, now we're done with this too. Now let's move ahead and identify where we have relative max and min. So this one is going to be a max because it's changing from positive to negative. So you have that since f prime, okay, please note that it's f prime, okay, changes, okay, from positive to negative, okay, at x equals negative 1. Okay, f has a relative, okay, max, okay, at the point, okay, at the point, what's that point? It's going to be negative 1 something, okay? So now you know that you need to plug the negative 1, and what's the other one? The 3. When I plug negative 1 inside your original, you have that that's 11 over 3, and when I plug the 3 there, that's going to be negative 7, okay? So this one is a point, negative 1, comma 11 over 3, okay? So, and similarly, you have that since f prime, what's the business there? Changes, okay, from negative to positive, and I'm going to use an extra piece of paper here because I'm running here out of space. Changes, what is changing? Let's say from negative to positive, okay? Let me put it here so you can see it, okay? Negative to positive, okay? At what's changing at x equals 3, okay? We can conclude that f has a relative, what's that, min, okay, at the point, okay, at the point, what's that point? The point is 3, negative 7. Okay, so that's what we have, okay, relatives, minimum, max, and we did justify our answer, okay? So this is your answer for this problem. You can see that I justify a lot, you wrote a lot, and that's normal in this type of problems. So for this problem, again, you need to find the intervals where f is increasing and decreasing and identify all the points that are relative maximums and minimums, and you need to justify your answers. As we saw in the previous problem, the justification is going to be the most important part of this process, because that shows that you're understanding what you're doing. Okay, so we have this f of x that it's equal to x squared minus 4 to the power of 2 over 3. So take the derivative of that, the derivative of the situation, you know that it's going to be 2/3 x squared minus 4 to the power of negative 1/3, and then the derivative of the inside, you know that that's 2x. Now, if you see it like this is not very pretty. So let's rearrange your derivative so it looks a little bit better. So you have at the top, you have the 4 times x divided by 3 times x squared minus 4 to the power of 1/3. Okay, so you have this situation. So when you have this as a derivative, you need to ask yourself, can this derivative be undefined at some points? And the answer is yes. I have the x in my denominator, so it's very dangerous to have this here, so you know that the x at plus minus 2, that's going to be a problem. So minus 2 and plus 2, those are going to be critical numbers. In addition to that, you are going to equalize your derivative to 0 and solve it, which you have for x equals 0, therefore you have that the other critical number is 0. So here are your critical numbers, right? You have 3. So again, I'm going to do my table here. So I would do my table from negative infinity to negative 2, negative 2 to 0, 0 to 2, and then I would do 2 to infinity. And remember, we are evaluating the derivative, okay? What are you going to do? I would plug the negative 3 and I would do it here because this one is factored out nicely. Okay, so this is negative. This would be what? This would be positive, right? Therefore, negative and positive, that's negative. Over here, I would plug the negative 1. This is negative. This would be negative, so negative and negative positive. Over here, I would plug the 1 here and here, so you have that this is positive, and this would be negative, therefore positive over negative, that's negative. Over here, I would select the 3 as plugging in here, so 4 times 3 is positive, 3 squared minus 4, that's positive as well, so positive over positive, because this is positive, it's going to be positive. Okay, so you can conclude that f is going to be here decreasing, here increasing, here decreasing, and over here increasing again. Okay, so that's what we have, so let's conclude. F is decreasing on what intervals? Negative infinity to negative 2, and the other interval that you have that it's decreasing is from 0 to 2, excuse me, because f prime is less than 0 there. Okay, the other thing that you have is f is what? Increasing on the interval negative 2, 0, and the other interval that it's increasing is from 2 infinity, because f prime is greater than 0 there. Okay, so we have these two statements. Now let's move on to the relative max and mins. You can see that it's changing from negative to positive, this is a min. From positive to negative, that's a max. From negative to positive, that's a min. So we have two relative minimums, and we have one relative maximum. Okay, so since they are saying here, the detail here on the instructions is they say that points, we also need to find the y part of your critical numbers. Okay, so which is not always needed, but in this case they are asking for the point. So plug the negative 2 here, you have that that's a 0. The 2 also is going to be a 0, so that's nice. And then if you plug the 0, that's going to be 16 to the power of 1/3. Okay, so I would leave it like that. Okay, something positive. Okay, so those are the points. Okay, so let's conclude. Since f prime, okay, what's the business of f prime? Changes, okay, from negative to positive at x equals negative 2 and x equals 2, what can you say? F has relative means, okay, at the points. Okay, here I'm clarifying that they are points because they look pretty similar to the intervals that we have. Okay, and 2, 0, right? Similarly, what do you have here? We have that since f prime changes, okay, from positive to negative, okay, at what was the value, x equals 0, we know that f has a relative maximum at the point. Okay, here I'm clarifying that it's the point because otherwise it looks kind of weird. At the point 0,16 to the power of 1 over 3. Okay, so that's what we have for the conclusion. As you can see, we were writing a lot because the justification is very, very important. Okay, so I hope that you find this video helpful. Bye.